People often talk about the tedium of coding and how it's really nice to be able to use AI to code gen a lot of things. Rarely do people talk about the joy of coding. Like sometimes there are just things that just feel good to do. And over the years, like one of the things I've really enjoyed doing is writing parsers with parser combinators. So I thought what I'd do maybe is kind of show people like why I love parser combinators. Let's start out with what is a parser combinator. Parser combinator is a function that takes an input string and basically parses the string, at least part of it, and returns the unconsumed part of the string and what it parsed. So let's do that. Let's write a function. Let's call it str, and um, we'll take the pattern that we want to parse, and what we'll do is we'll return another function that takes an input string. And what it will do is it will say like if the input string starts with the pattern, then we'll return an array which will be the unconsumed part of the string. So we're going to take the substring of the string with the length of the pattern, followed by the pattern, because that's what we found. Otherwise, let's return null if a parse fails. And so let's make a parser, call it hello parser, and I'll say I want to parse the string hello. And if I run this right now, and I run hello p on the string hello world, let's see what the result is. And you can see that the result is world comma hello. The first string is the unconsumed part, and the second one is the parse result. So let's run another parser. Let's call this world p, and we'll look for the word hello. Now, if I try to run this parser on the string hello world, you'll see that the second result will be null because it's not prefixed. It doesn't start with the word hello. So what we need to do is we need to be able to chain the hello and the world parsers together. So let's write a function to do that. Let's call it seek for sequence of parsers. Let's take a list of parsers. And again, we're going to return a new function that's a parser. And what we're going to do is we're going to create an empty a results array. And then we're going to loop over the parser. So let's say for each parser in our list of parsers, we're going to get a result by applying that parser to the input. And if that result is not equal to null, so it's basically parsed it, we're going to set the input string to be the unconsumed part, which is the first part of the result, and we're going to push the value from the return parser onto the second onto the results array. Else, if the parser failed and we got a null, we're just going to return null. That means the whole sequence failed. Finally, at the end, we're going to return, once again, the unconsumed input, followed by the results array. So now down here, I'm going to use my new sequence operator, and let's call this hello world p, sequence hello p comma world p. And now I should be able to parse the entire string by using the hello world p operator. So now if I run it, you can see it's parsed both of those, and it's returned an array, and then the unconsumed string is now completely consumed. It's empty. Well, that's awesome. But what if we wanted to parse hello world or world hello in either order? Well, for that, we need an OR parser. So let's say we list of parsers again, and we return, once again, a new parser. And basically, we loop through the list of parsers. This time, we'll invoke uh, parser on the input. And we're going to do this in a greedy way. The first one that succeeds, we'll just use that one. Now, there are other ways to do this, but for simplicity, I'm just going to use a greedy algorithm. So I'm going to say if like r is not equal to null, uh, basically I'm going to return r. That's basically the result of the parser, the first one that succeeds. Otherwise, if we reach the end and none of them succeeded, we return null. So now let's come down here and let me create a new parser. Let's call this one world hello p, and this parser will look for the string world p followed by hello p, or world followed by hello. And then I'm going to create a parser called both, and it's going to OR those two together. So hello world p, comma world hello p. And so now we should be able to invoke both on that or on world hello. So if I run this, we should get 2 successes. Okay, that's cool. But the results array is not what I'd like. I mean, sometimes you want it just to return the strings that match, but sometimes you'd want it to construct objects or um, parse values and so on. So for that, let's create a thing called a pmap operator, which takes a parser. And once again, let's return an input. Sorry, a new parser. And what we're going to do this time is we're going to uh, execute the parser on the input. Oh, sorry, we need to take a function f to apply. And we're going to simply return, first we need to check if it's not equal to null. And then we're going to return a value where we'll return the unconsumed input as normal, but we'll apply a function to the value for returning it. Otherwise, uh, we we return null. Oops. And then up here, sorry, I spotted this is a problem. This shouldn't be here. This should be inside the parser. Okay. So now, what if instead of having this as an array, I want to basically concatenate these strings? Let's put a pmap operator on that, and um, can take the results of the array and concatenate them together. Likewise, I could do the same for this one. But I'm going to do it in reverse. So no matter which way it's parsed, it's always going to return hello world. So now if I run this, rather than getting two arrays, whoops, I got an error there. Let's see, what did I do wrong there? So, oh, I'm missing a parenthesis here. That's okay, let's run this. Now instead of getting 2 arrays, I get hello world as both the string results. And I'll end it there.